Hi everybody, in this video we're going to talk about negating nested quantifiers. Remember, when we negate quantifiers, we have to change the quantifier and negate the predicate. When you're negating quantifiers, it will flip from universal to existential or existential to universal. So for example, if I have for every x p of x, for every will become there exist and I'll have not p of x. If we had there exist x p of x, there exist turns into for every, so my negation is for every x not p of x. As we move on to negating nested quantifiers, we're going to have to switch the quantifier and apply negation to the predicate inside the expression. We'll start by looking at the negation of for every x, for every y, p of xy. The universals for every will switch to there exist. We'll have there exist x, there exists y, not p of xy. Let's look at an example. If I have for every x, for every y, x plus y is greater than 0 over the reals, we know that this is false. There are plenty of examples of numbers we add together and the sum is not positive. Think about -1 plus -2. Because our statement is false, we expect the negation to be true. Our negation is there exists x, there exists y, such that x plus y is less than or equal to 0. So we have flipped the quantifiers and we negated our predicate. This we know to be true. If we go back to our example of -1 plus -2, we've satisfied our statement. Now let's take a look at the negation of for every x, there exists y, p of xy. This time we've mixed universal and existential together. When we negate, for every becomes there exist, and there exist becomes for every. So we have there exist x for every y, not p of xy. Let's try for every x, there exist y, where y is greater than x over the reals. This statement is true. No matter what value of x we pick, we can always find a value of y that's greater than our value. Because our statement is true, we expect the negation to be false. Our negation is there exists x for every y where y is less than or equal to x. This negation says there is a specific value of x that is greater than y for all y values in the reals. We know that's false. Because there is no biggest number in the real numbers, we can't find a value of x that satisfies this condition. Let's simplify the statement below so that the negation symbol occurs only directly next to the predicate. We have the negation of there exists x, p of x implies for every y, q of y. As a reminder, the negation of p implies q is p and not q. So in our negation, the there exists becomes for every, so we have for every x, p of x. Our implication is replaced with the and. For every y becomes there exists y, not q of y. The only negation we have is right by the predicate q of y. Let's try that again with not there exists x for every y, x is less than y, or x is less than or equal to 0. We first switch the quantifiers. We get for every x there exists y. For the parentheses, we're using De Morgan's law. We're going to flip x is less than y to its negation, x is greater than or equal to y. Or switches to and, then x less than or equal to 0 flips to the negation x is greater than 0.